It is only relative. Relative, right? Okay. Now, let me do this. I'm going to separate the screen so that we can work on these different problems. It says simplify. Write your answers in scientific notation. Okay? Now, Bella, you're going to help me with this one. Okay? This first one says 3.2 times 10 to the 7th divided by 2.0 times 10 to the 4th. Well, we do, but here's the thing, Bella. I want to think about this as actually two separate fractions. You have your calculator with you, so I want you to use it. So think about this as 3.2 over 2.0, right? Times 10.7 over 10.4. Now, Bella, I think we can do something with this. What can we do with the tens? 10 to the third, right? We just subtract those exponents. Now, just one on the bottom so I don't have to write it. But what do I get? What is 3.2 divided by 2.0? 1.6? Now, Bella, one thing that we need to do before we move on is ask ourselves, is this in scientific notation? Is this front number between 1 and 10? Yeah. It is. Okay, and we've got times 10 to the third. Then that all looks good. All right, that's perfect. We don't have to do anything with that. Nice job, Al. All right, now Taylor, you're going to help me with this one. Okay? Now, Taylor, what do numbers right next to each other with parentheses mean? It means multiplication, right? So basically, this is saying 2.5 times 10 to the third times 6.0 times 10 to the second, right? I don't need those parentheses. It's just all being multiplied, right? Okay. So what would you like to multiply, just looking at this first? 10 to the third times 10 to the second, what's that give us? 10 to the fifth. I just add their exponents. Beautiful. Okay. Now I need to multiply 2.5 times 6. Can you do that in your calculator? Just tell me what it is. Do you see why if you didn't have a calculator, this is easier? I mean, it makes it easier than multiplying these big numbers. So you said 15? Okay. Now, Taylor, the one thing we have to do is this in scientific notation? It's not, because my number out here is bigger than 10. So my decimal points here, I need to move it one place there. Do you agree I made it smaller? So what happens to the exponent over here? I add 1 to it, because I just moved one place, right? So now it's 1.5 times 10 to the 6th. If this number gets smaller, then the exponent has to get bigger to keep it balanced, to keep it equal when we multiply it back out. All right, now I'm happy with this because that's in scientific notation. All right. James, tell me with this last one. This last one's a little weird because they're not really asking us to do anything, but they said write it in scientific notation. Is it not in scientific notation?
No, it's not between 1 and 10.
It's not between 1 and 10. Okay. Right now, it's 0.4. I need to move it over 1. Did I make it bigger or smaller? I made it bigger. So what do I do to the exponent?
The exponent is small.
By 1. Done. Okay. We took 110 and multiplied it by the 4, so there's only 5 left. Okay. Nice job. Nice job. All right. Let's look at the next example.